So our next speaker, I've actually known him for like a decade or something. It's been a very long time, right? But when he's not coding in R and Stan, and I'm sure other languages, but particularly Stan, he's a big fan of Stan, he's DJing underneath. Now, I've seen his name before, his DJ name. I've never understood it because of the way he spelled it in Leet speak. But pronounced, it's cyclic. Like a cyclic process. All right, I thought it was cooler than you guys do. All right, cool. Everyone, please welcome Daniel.
Everyone else started with a joke, and I won't because that'll slow us down to get to happy hour. So oh yeah, and I forgot. I didn't include this slide. This is a new talk. It got finished like back there a couple minutes ago. Who am I? I don't know. I've won a couple hackathons now. I've competed in 3, and the third one I won a prize there too. So I've won a couple hackathons. That's why I'm talking about how to win a hackathon. I've helped develop Stan, the open source statistical probabilistic programming language. I do code in R, Python, C++, Stan, a bunch of other stuff. All right, so here's the one that I won in March 2022, a few months ago. It was the MIT Sloan Sports Analytics Conference hackathon. It was presented by ESPN and NHL. It was Thursday, 9 a.m. to 4 p.m. That was it. That was the extent of the hackathon. And then they had the finals on Saturday at 8:30 a.m. Why 8:30 on a Saturday? I don't know. Very little guidance. They didn't tell us what we were supposed to do. They just said, here, go do something. All the judges were experts in hockey, which I am not an expert in hockey. This is a new sport for me. What they gave us was NHL data, and it was tracking for the 2020 Stanley Cup Finals, so 6 games of the Stanley Cup Finals. They gave us tracking data, X, Y, and Z positions, for all 40 players. There are only 6 players on the team at a time on the ice. We have 40 because you get to see the bench. The puck, the referees at about 100 hertz. And by the way, this is not time aligned to the game time. This is absolute time. And so you have to figure out what time this happened. We have play-by-play data. So we had 2 streams of play-by-play. Official scores data. So they'll come in and say that was a goal. It happened at 12:02. And they'll mark it down and say who did it, who the assist came from. And they also had automatically generated data. They had other data like rink dimensions, player info. We knew height, weight, age, where they were born, their parents' names, I think, some random stuff. And this is kind of a fun talk because our project 1, this is going to be a talk within the talk. I'm going to give you a very short version of my talk, and then we'll get into like how you can actually win hackathons. So here we go. So this is a Sloan goalie card. And what we focused on was, first of all, the meta problem is that the valuation in hockey is too result-driven. In NHL hockey tracking data, there was only one winner of the full 2020 Stanley Cup Finals, and that was the Tampa Bay Lightning. So that's not enough to do anything with. There were only 6 games, and there were only 33 total goals scored. So what we wanted to do is we wanted to turn that into something that's process-driven. So what leads to this win? So we looked at the process. We found that people take shot attempts. There are over 500 shot attempts on the 33 goals scored. You can see I used R for the graphics. Sorry, there's more background that you can't see, but that's OK. So we framed this into a problem. Does goaltender depth matter? So that's the distance that the goalie is from the center of the net. And why did we look at this? The first reason is that it turns out NHL goalie depth data is not public. So no one's really seen this outside of NHL analysts. Is a goalie more or less conservative? Conservative meaning if you're further out, you're aggressive. If you're further back, you're defensive. And fans, all of us, might have a sense of where a goalie stands, but we can't quantify it. So we don't know. Does the depth of play change shot percentage? That should be an obvious question that we'd want to know if we can change something about a goalie's play. And this is all part of the process. So what we did was we modeled shot percentage with goalie depth included, since this is a new covariate that we hadn't seen. I wrote a Bayesian logistic regression in Stan, and it had the distance and depth properties in it. And what the output of this model said was that there is a difference between the two goalies. And you can kind of see it from the heat map here. I'll skip through this slide for a little bit because this talks about the exact goalie differences. But it did lead to how should we improve the model? Where can we do that? Should each goalie play differently? That's the ultimate question we want to get to. What we did in that time was we built an actual web app, which I won't pull up right now. I have more slides later. And then thank yous. And there was a team. I found a teammate. We did this all in a day. And now I get to talk about the strategy for winning a hackathon. So it's pretty simple the way I see it. There are 4 steps. You define a problem. You specify a solution. You implement the solution. And then you build some sort of interactivity into it. I'll get into that just a little bit. All right. So we got time. All right. So the first thing you want to do is actually define the problem. This is really important. You want to understand why it matters and to whom. You want to understand what game you're playing. So each hackathon is different. You want to get in there. You want to understand who's judging it, why are they judging it, what are they looking for. If you can't find a problem that they understand, it doesn't matter what you do. You're not going to win. And then you want to communicate this to people, and you want them to believe that it's a problem that you should look at. If you do that, just that, don't even come up with any solution, you'll be in the top third. I guarantee it. Don't need to do any coding, nothing. Spend the whole time just to find this problem. So in the slides that I have, this is the slide that kind of spoke to the judges. Does goaltender depth matter? I pulled up some information that was from the NHL goalie training manual. And the people were telling me that there is a difference in play now from 20 years ago. They do think it matters. And we identified that they don't have data for this. The second step is to specify a solution. We're not talking about any implementation. What we want to do is describe a solution and understand whether or not it solves the problem. And what you really want to do is communicate to them that if you could solve this problem in this way, they wish they had it, right? You do that much and you're in the top 10% of any competition that you'll get into. That's it. You don't have to do any coding. You could paint, Microsoft Paint it, and it'll be okay. For us, this was this slide here where I showed a stand model that actually incorporated both the distance of shots, which people have seen before, but also the goalie depth. And so now I've painted them a picture that we might have something that uses the goalie depth to help us predict what a shot percentage would be for an offensive player. The third is to implement the solution. And so this is where you actually have to put in work, and you have to be really pragmatic. Most people aren't able to make it this far. Most people aren't able to deliver anything of substance because they bite off too much. So you want to go and narrow it down, be pragmatic about what you can build, and you want to remember that all this is a proof of concept. If it passes the smell test, if a judge goes and looks at it and says, I can kind of believe that, maybe, that's it. That's all you have to do. All right, and the thing that you want to focus on when you're communicating this is focus on your accomplishments. Don't tell them where you could have done better. They don't care. They don't know. Just say what you did. So for us, we built out this web app. It had 2 goalies. You can actually flip through the goalies. You can go and look at each of the shots, play by play, see what distance it was and where the goalie was at that time. And we did this. We let them sit on that. And remember, they don't know what you could have built. You have that in your mind. Doesn't matter. You want to tell them what you did build and how that actually solves the problem. You do this, and you'll end up as a finalist. I'm pretty sure you've beat out almost all the competition, if not all. The last thing you can do to really seal it is build in some interactivity. Give the user something that they can do something with. So the way I think about it is counterfactuals. a what if they can answer a what if question off of whatever you built, then you've done something beyond what they expected you to do. So for us, it was, what if the goalie actually stood a little further out from the goal? What if he was playing closer in? What if, and you don't have to lay out everything. You want the judges to start going, oh, I can answer this question that I'm interested in. Once you get there, you're sold. And so the communication key here is that you want to provide the potential to provide insights. You don't have to provide it all to them. You just want them to believe that you possibly could do it, at least at the hackathon setting. Great. All right. And so now I'll talk a little bit about the work that you need to do. So if you're competing in a hackathon, I would suggest you come in with the tech stack already decided. Slack for communication, GitHub, Git for code. I used R, Shiny, and Stan. A little less Shiny for this project, but it was still there. My teammate used Python and JavaScript to build the web app, and so we split it that way. But it doesn't quite matter which you choose. Just choose something that you're comfortable in and can do something quick. Please don't ignore DevOps. If you've all been ignoring DevOps, think hard. You want continuous integration, you want deployment, and you want testing. Even from the start, you should think about this before you enter. That way, when you do something, you see the results immediately, and as you're going through this, you can iterate very fast, and you don't have to worry about, oh, how do I get this in front of somebody? That should all be settled before you enter. For picking teams, it's tricky. You can go farther with others, but it's definitely harder to align when you have more people. So think hard if you enter these competitions, who your teammate is. And you absolutely cannot micromanage. You have to split responsibilities. If one teammate says they're going to do one thing, and that's not you, you have to let it go, even if it fails. You just can't do it. So this makes actually choosing teammates very hard. This is why you end up arguing about what the problem is, what the solution is, and how to implement. And the last thing I want to tell you is to focus. So focus on the problem, the solution, the implementation, the interactivity. Remember to keep communication to the judges in mind, and remember to play the game. And then keep everything else out. If someone wants to argue about agile processes, like wrong team, like that's not for a hackathon, sorry. All right, and so if you're thinking about entering, hackathons are hard and they are stressful. They're very, very high variance game because rules differ to begin with. Every hackathon I've seen has a different set of rules, different set of judges, different amount of time. This particular hackathon, they let us finish and do a preliminary result and then go away for 2 days and then present our final. We didn't take advantage of that time, but different rules. Remember, performance here doesn't reflect your personal ability. Please don't take this as like a measure of how good or bad you are at any skill. Like, it's okay. You can lose at hackathons and be fine. You can win at hackathons and not be great. It's okay. Take it as an opportunity to learn how to work under pressure, how to communicate as fast as you possibly can, and to focus, and often without any of the other overhead of workflow tools. Just like a piece of paper, you slide that back and forth. You have GitHub issues, just open, close, done. Finally, this is my last slide. Thanks to everybody. My teammate, Fabrice. That QR code is my LinkedIn if anyone wants to connect with me. My family gave me a lot of support, always a stand team. Jared, Nicole, and the NYR conference team, you've been great. Thank you. Let's go to happy hour.
Thank you very much.